Welcome to the Ultralight Airplane Workshop. My name is Leon. Let's finish attempting to make a carbon fiber sample using Resin Infusion, but failing. If you haven't seen part 1 of this attempt to make a carbon fiber part with Resin Infusion, go back and take a quick look at that one. Well, let's see how this part turns out. The next thing to do is to mix up some epoxy and infuse it into our part. So I tried to find out how much epoxy I would need in order to fill up the resin mesh, the flow media. I couldn't find anything for this specific media from where I bought it, so I was trying to look for something similar. What I found was 700 grams per square meter. For the carbon fiber, you can use roughly equivalent weight of the carbon fiber. Now I remember from the previous sample that I did with the wet layup, carbon fiber was around 50 grams, so I need about 50 grams of resin for that. I think I have around 2 square feet, maybe a little bit more of the flow media. Let's just assume that a square meter and square yard are about the same. Per square foot of resin will weigh, for this flow media, 700 divided by 9 should give us roughly a square foot. Good enough for what we're doing. That's 77. I think I have 2 square feet, so let's multiply by 2. That's about 155 grams of epoxy to fill the flow media. So let's add in that 50 grams for the carbon fiber. So that's about 205 grams. I'm going to need more to fill in the tubing on the input side, and I still need to leave a little bit in the cup. Let's add another 50 grams. So that'd be 250 grams total weight that I think I need for the resin. And if I start running low, I'll just mix up some more and put it in. Now the epoxy I'm using is the same as last time. So I'm using Aero Epoxy, the PR 2032 resin, and I'm using the hardener, PH 3663 hardener. This hardener is the 1.5 hour working time, and it's thin. And that's what you need when you're doing resin infusion. You need a thin epoxy in order for it to be pulled through by the vacuum. Thick epoxy might work, but it will take far longer. So this is a good epoxy to use for this resin infusion. This epoxy mixes by 100 parts resin to 25 parts hardener. That means 80% of the epoxy is going to be resin, 20% is going to be hardener. Let's figure out how much resin we need. So we got our 250 grams, and we're going to multiply that by 0.8, which would be 80%. So resin needs to be 200 grams. That means our hardener needs to be 50 grams. When I weighed out the epoxy on the previous video, I had a little trouble getting the exact amount that I wanted of resin and hardener. The cans were pretty full, and I had a hard time getting the amount that I wanted. So this time I'm going to see if I can cheat a little bit. I bought these monster syringes. I'll use one for pulling out resin. I'll use another one for pulling out hardener. And I should be able to get much closer to what I want. Get our scales going here. Now, I don't know where they found these pieces of tubing that they stuck in here, but they don't stick very well. But we'll make do with what we can for now. Let's pull it out. Now this might be a little bit thick because it is a little bit cold. It's not just a little bit thick, it's a lot thick. I wonder if I should have heated this up just a little bit before we started using it. Now it's 74 degrees here in the shop. But this stuff is really thick. Okay, this is going to take quite a while to do. So I will shut you off for now until I get closer. Using that syringe to try to suck out the resin didn't work very well at all. Resin's just too thick. But the hardener is thin. So the syringe should work pretty good for that. What I did was I took the cup, set it underneath the 1 gallon opening and just poured it in until I got to where I thought, the rest of this is going to have to be resin, and I stopped. It turns out that was 186 grams of resin. So then what I did is I calculated how much hardener I would need with that much resin, and it turns out I need 46.5 grams of resin. So let's use our syringe with that. Let's get our self-metered up again. We're at 0, so let's pull out some hardener. Oh yeah, that's much easier. Okay, I'm guessing that's more than enough. So let's put out 46.5 grams. And I hope I didn't make a mistake and that this will work. That's halfway. There's 40, 2, 3. 46.6. Okay. I've got the exhaust fan running there in the background. You'll be able to hear it because I do not want to whiff this hardener. That stuff is hard on the sinuses and not too good on your body either. What I'll do next is I will stir up this resin. I'm going to use a very gentle motion to do this. I do not want to put air bubbles into my resin. So I'm just going to very gently mix it up. And I do have to be kind of gentle with this particular cup because we're near the top anyway, so we can't get too vigorous. What I've done is I've transferred the epoxy from the mixing cup into my holding cup. I'm going to let it set for just a little bit, let some of these air bubbles rise up out of there. And as soon as that's done, I'll pull the vacuum on this. By the way, I've closed down this clamp, so it should not pull anything until I release it. And what we'll probably do is start out slow. Go ahead and pull the vacuum. I'll open it up just a little bit. Looks like the air bubbles are coming out. While we're waiting for that, I'll do a little cleaning of the equipment. Alright, let's pull a vacuum on this thing. Okay, we got a full vacuum. Let's infuse it. The dark area on the left is the epoxy flowing into the carbon fiber and through the mesh. The tree-shaped, lighter colored areas are flowing rapidly from left to right. Is air that has leaked into the part and is being pulled toward the vacuum on the right side. Here, the air appears to possibly be entering in 3 places. In the middle, toward the near side, and toward the far side, all on the left. But I can only see it appearing close to the front edge of the carbon fiber. It's at this point I'm starting to panic and trying to figure out where the air leaks are. Where you see me poking my finger, I thought I had a pinhole leak right there above the carbon fiber. So here we can see the repercussions of one of my mistakes that I mentioned in the previous video. If I had extended the carbon fiber all the way to the left underneath the mesh and the spiral tubing, it would have been easier to figure out where the leaks were. Most likely I would have been able to see that the leak was appearing at the port and then running, some of it coming out the middle right there at the port, and then most of it going to the ends of the spiral tube and then coming out. Here I have turned off the vacuum at the resin trap and I've clamped off the input line, trying to slow down the process so that I would have some time to figure out what was going on. Unfortunately, I did not figure it out. Here are some close-ups that I took of the air flowing through the part, and in some places the air was kind of static, and that was over on the right-hand side in the corners. When I was taking these close-ups, I'd already decided that I was just going to let the air keep leaking since I couldn't figure it out and cure overnight and see what would happen. I thought it'd be kind of an interesting experiment to figure out what would the air leaks do to the part. Would it be completely destroyed? Would there be no epoxy in the part? We'd find out. Well, the part has cured overnight. It's been about 24 hours since we finished. It cured at about a 71-degree temperature. I left the vacuum on it for about 15 hours. And as just a quick little review on that pump, that was the first time I had run that pump for any length of time. I had only run it for just little short bursts before that. And it got pretty warm. Not so warm that you couldn't touch it, but it did get pretty warm. And it got warm enough inside that you could smell it. It had that very hot smell to it for a little while. I'm guessing that some of the paint and enamel inside got a little warm and baked off some volatiles. But it ran okay for 15 hours. It kept the same vacuum level, which was 24 inches of mercury, and it did that the whole time. So far I'm happy with that pump. One additional thing I did, since it wasn't a high temperature in here, about 71 degrees, for the last 6 hours, I put a small heating pad on it. It's just a personal heating pad. So it didn't get very hot. I'm guessing the temperature is probably about 85 or 90. So it raised the temperature up a little bit. I did that just to try to ensure that it would be cured enough after about 24 hours that I should be able to take it apart without any issues. I've already taken a little bit of this apart. I've taken the pump off, taken the hose off from between the pump and the resin trap. Got rid of my fancy dancy little holder that I had holding my resin cup coming in. And I've cut the line going to the resin trap from the part. One of the first things I wanted to try out is how well putting the release agent into the resin trap worked in order to get resin out of the trap that went in. Now we got quite a bit that went in, and part of that reason is that because the air leak that we had, a tremendous amount of resin came out because it was replaced with air inside this part. So we got a lot of it into the trap. And at first I was a little bit worried because I turned it upside down and whacked it a couple times and nothing came out. But I whacked it a third time and it came out. So I'm very pleased that the release agent worked at getting this excess resin out of the resin trap, so I don't have to worry about building up every time I use it. One thing I do want to say is that I did come down and check on this part every hour or so. And even after about 4 hours on this exit port line, I was able to see air bubbles coming up through here, which means the epoxy was still liquid enough to allow air to come through here. From that then, I know that I have to keep the vacuum on here at least that long. I want to keep the vacuum on at least until the epoxy cannot flow anymore. So I have to keep the vacuum on somewhere more than 4 hours, and over time we'll start figuring out what that is. Another thing is that because I had epoxy going into the trap, got a little bit of epoxy here on this inlet port. And what I've done right now is I just got a little 1/8" drill bit and drilled through there. It didn't close it up, but I can see that there was a little bit of an epoxy buildup in there, a small film. So I'm going to have to remember to keep that cleaned out. I don't think I can get release agent in there. There's actually several different parts in there, not all exactly the same diameter, which means I probably can't push any epoxy out that would build up. I think I'm going to just have to drill it out, but that's fine. Well, I do believe it's time to start ripping this off and seeing what we can learn. But sticky tape came off very easy. I'm a little bit surprised at how easy that came off. Well, the release agent worked great. That part came off very easy. That was even easier than the PVA. Well, now this is interesting. Don't know if you'll be able to see it. There is some yellow, and I believe it is sticky tape that came down through this flow media and came down to the bottom. So that's kind of interesting. I think putting sticky tape underneath the bag was probably a bad thing. I'm going to try to avoid that from the future. Well, to me, it looks like this input port is sealed pretty well. I don't see any wrinkles that air could have gone through. So I'm not... Oh, I'm sorry. That was the exit port. Let's try again. yeah. Okay, I think I see where the air leaked into the bag. Yes, I do believe. Okay, I think I see what happened. I had a wrinkle. You're not going to be able to see it, but I'll put it up here for you. I had a wrinkle right here between the bag and the sticky tape that was underneath, and it's let air come up through that wrinkle. So that's all it took, was just a tiny, tiny little hole to let lots of air in. And that's what caused the part to fail. So we were close, didn't make it. Last night, while I was waiting for this thing to cure, I went online and bought some ports that are specifically made to be used. What I should have used. So next time, hopefully we won't have a failure from that. What I'm trying to do here is trying to keep the carbon fiber flat while I pull on the peel ply. I don't want my carbon fiber to bend and develop cracks in the fibers. Oh my, this is much thinner than the wet layup that I did. I can tell that it is really thin. And just being thinner has made it more flexible. Now, I'm looking at the surface of it, and it definitely did not fill in the surface. In those very small places in between the crimps of the toe, definitely did not fill it in. And I didn't expect it to with all those air troubles I had. But boy, that'll make this a lightweight piece. But you know what? On the top side, it looks pretty darn good. Looks very good on the top side. Well, I'm going to go trim this off with the bandsaw. And then I'm going to check the thickness. I'm very curious about how thick this is going to be. I just finished trimming the new piece on the bandsaw. I don't know if you can see from this camera, but the surface finish on this one is much duller and it's uneven compared to the surface finish on this one. If we hadn't had that failure with the air leak, this would be almost a glassy, smooth finish, shiny finish. Now, it wouldn't really be fair to compare the weights on these, but I'm going to do it anyway. This piece, because of the failure, I would not ever use this in a structural part of the airplane. But something like this I think would be fair to use in a cosmetic part of the airplane. This will be lighter than if we had not had the failure with the air leak. So it might be an interesting idea at some point in the future for some cosmetic piece. Perhaps a fairing or perhaps a console to play with, letting just a very tiny bit of air into that part while it's being formed, let air in, and see if we can duplicate this. Because it's very uniform. There's from one corner to the other, it all looks identical. I really cannot see any obvious flaws other than it just did not fill in the surface. Like I said before, just between the crimps, you can see it just did not fill it with epoxy. And on the back side, you can't even tell. It's almost completely filled in here on this back side. And by back side, I mean the side that had the peel ply on it. Let's do a little quick test, compare thickness on this. Now this is the sample that I did a couple months ago using the PVA method for the release, the mold release, without any vacuum bagging. So this is just a wet layup. So the thickness on this was about 29. Yeah, it's about 29.5 is what I'm reading. There's 27. So that's another issue with just the straight wet layup. It's not going to be completely uniform thickness. There's 27.5. There's 28.5. But clearly it's not uniform. 28.5. Let's see how this part worked out. Now I believe the thickness on this one would be the same even if we had not had that air leak failure. So let's find out how thick this is. 20. 21. 21. 21. 20. Wow. This is all within about 1,000th or 1,000th and a half. 21.5. Yeah. So all the thicknesses here were within about 1,000th and a half. So plus or minus about 3/4 of 1,000th. Of course, that's not strictly accurate on here, but close. This one varied about 3, almost 4 thousandths across it. So we got a more uniform thickness with the vacuum bag, which is what I would expect. And just for grins, let's weigh this. I have a fancy smanchy little cup that I use for doing this. I put a little slot in that'll hold up the piece as I weigh it. So this is 83 grams. And by that, I meant the original piece with the wet layup. Aha! Now this isn't really fair, but this piece using the vacuum bag and vacuum infusion is 60 grams. So it's clearly lighter. We clearly have far less epoxy in this. If we had not had that failure, this would be heavier. It would have more epoxy in it. Not a lot. Just based on how much I can see did not get filled in. I'm guessing about 5% more would be my guess how much heavier it would be. So let's call that 3. So about 63 grams. Not bad. Not bad at all. Okay. Well, what I'm going to do then is in 3 days, I'm going to get some more input ports that should be much easier to use, and we should not have a leak as long as I use them correctly. And we will try this again. Well, let's review what went well and what didn't. I believe the Home Depot whiteboard worked great for a flat surface. I was very pleased with that. The Free Coat release agent worked fantastic. It worked great as a mold release agent on the whiteboard, and it worked pretty good as a release agent in the resin trap, letting the excess resin that got in there to just fall out after I tapped it a few times. The flow media worked pretty well. That's pretty foolproof. I think that way that was used worked good. The spiral feed tube worked pretty good. The vacuum pump worked great. The resin trap worked great. Using the masking tape to cut the edges of the carbon fiber worked great. We did not get any fraying on those edges. Using the masking tape to tape down the corners of the various layers in the layer stack worked pretty well. After I was reviewing some of the video, I realized I made a pretty big deal about not putting masking tape on the in-feed edge of the carbon fiber. But then I stuck a whole bunch of masking tape over on those corners where the feed was coming in. So I still need to do that experiment to see if the hardener or the resin will dissolve the adhesive on that masking tape. So the only significant failure on this attempt was the leak on the input port. I do not believe we had a leak on the output port. At least after I took the tape off, I couldn't find where there might have been one. On the input port, after I took the sticky tape off, I could find where there was where the leak probably occurred. And that was just carelessness on my part. So if I had been a little more careful on that, we probably would have had success. So overall, I was very pleased with the result, even though we had a failure. Learned a great deal, and we'll carry on.